Hi guys, we are going to be doing 1.5, which is rewriting equations and formulas. This is a new section. We're skipping 1.4 for now. So in if you are well, when you do your table of contents, we should go from 1.3 to 1.5. So make sure that you have your page numbers and you're able to put that on in your table of contents. So we're going to split this up into a couple days, most likely. And first thing we're going to talk about is what is a literal equation is. So a literal equation is an equation with two or more variables. One of the main thing that we're going to be doing is we're going to be rewriting equations by solving for one variable in terms of the other. Okay, an example of a literal equation might be y equals 3x plus 1. Some of you recognize this type of equation. It makes a line when you graph it. If you don't remember, that's fine. We're going to go over that at some point. But the important thing to remember about literal equations is that we will not necessarily, well, in all the exercises we're doing, we're not going to be obtaining a numerical solution for the variable. And in the past, what we've been doing is we've been getting like x equals 5 or x equals, or maybe y equals 1/2. Those are the kinds of solutions we were ending up with. But our answers are going to look a little different in this section because we're going to have two or more variables. But the overall goal is that we're still going to be able to get the variable by itself. So that's been our overall theme for the last like week and a half, 2 weeks, has been to get the variable by itself. And we're still going to be doing that. So we're going to use the same inverse operations to solve for that variable. Okay. So it's the same steps and same process as regular equations, but it's just going to look slightly different. Okay. So for this equation, make sure you copy it down, copy down the instructions, and we're going to solve the equation for y. So remember that all that means is we're going to isolate it. Isolate y. Okay. So this y is what we want to get by itself. And notice that we have an x in the same equation. We haven't really seen that before. We've seen like maybe multiple y's, but we haven't really talked about a y and an x in the same equation. So the rule is still the same. Okay, so think about if this was y equals, or sorry, y plus, I don't know, 4 equals 3. What we would do is we would subtract the 4 from either side. Okay, and then that's how we would solve for y. We would finish that and say y equals -1. For this one, it's the same idea. The only difference is we don't know what x is. X is always good. It's a number. We just don't know what it is. So just like we're subtracting 4 from the simpler equation, we're going to just subtract 2x. Okay. Notice how I'm not lining it up right underneath my 3. I'm doing that on purpose because what tends to happen when we line unlike terms up is we tend to add them. Like the most common mistake that I get, or we tend to combine them, I'm sorry. So the most common mistake that I get is that students will say, okay, well, y equals x. Those two things cannot combine. So we have to keep them separate. Okay, so our two x's cancel out here. So we're just left with y. And 3 and -2x, again, cannot combine. So all you can do is just bring them down. Now, have we isolated y? Yes, we have. Y is by itself, and this is our answer.